Our last lesson on quantitative aspects of chemical change is going to focus on percentage purity, right? Cool. So, how do we define percentage purity or how do we find it for a given sample? So, we would normally say percentage purity can be calculated using the following equation. So, we would say the mass of the compound or substance we are interested in divided by the mass of the sample. And because it's a percentage, the entire thing is multiplied by 100, right? Let me see. Okay, so the whole thing is multiplied by 100. So let us take an example to kind of further explain what is it that I mean. So consider that shells, those seashells, contain a chemical compound called calcium carbonate as well as other minerals. And now here is Tabo. Tabo wants to know how much of calcium carbonate we can actually find in a specific shell, right? And then he finds a shell, he weighs this shell, and he finds that this shell has a mass of 5 grams. So this 5 grams is actually the mass of the sample. So M sample is equals to 5 grams. Cool. And then let us read further. And now he performs a number of experiments. After performing those experiments, he finds that the mass of the calcium carbonate plus the crucible. So the crucible is just a container that we use to heat samples or compounds in, right? And he finds that it is 3.2 grams. So this is the mass of the calcium carbonate plus the crucible is 3.2 grams. And they say the mass of the crucible is actually 0.5. So how much calcium is in the shell? When they say this, they actually want you to determine the percentage purity. So now, this is the thing we know. So the mass of our compound in this case is calcium carbonate is actually going to be 3.2 minus the 0.5 of the container, the crucible that he heated this sample in, right? And that value is 2.7, right? If I'm not mistaken, 2.7 grams. So now we actually have the mass of our compound. So we can proceed and find the percentage purity. So the percentage purity is just going to be the mass of my compound is 2.7 grams divided by the mass of the sample is 5 grams. This entire thing, I said we multiply it by 100 and you're going to find that it is 54%, right? Let us do just one more calculation. Okay, so this is the second question that we can look at. So the question says that limestone is mostly carbonate, right? And then Jake wants to know how much of why am I saying carbon? Calcium carbonate, right? So limestone is mainly calcium carbonate. And Jake wants to know how much of calcium carbonate is in a sample of limestone. Cool. And then he finds a sample that weighs 3.5. So we know that mass of sample is going to be 3.5 grams. Okay, he then adds concentrated hydrochloric acid to the sample, so HCl, and the equation for this is given as such. And then it's balanced, so you all remember always make sure that to check that your equation is balanced. And then if the mass of calcium chloride produced is 3.6 grams, so they give us the mass of calcium chloride, which is 3.6 gram. What is the percentage purity of the sample? So just think about it a little bit in terms of how would you actually go about doing this calculation. So we can say, all right, cool. So we know that if you write for 1 mole of calcium carbonate, we have 2 moles of hydrochloric acid, which will yield 1 mole of carbon dioxide plus 1 mole of calcium chloride plus 1 mole of water, right? So we have mass of the sample. We also have the mass of calcium chloride. So because we're looking for this, we compare the two things that we have the mass value for and the unknown, the ratio, and we compare the ratio of the two things that we have the known values for as well as the unknown. So we can say that the ratio of calcium carbonate to calcium chloride is 1:1, 1 mole, 1 mole, right? So meaning that we can, if we can, the number of moles that we will calculate. Why didn't I write this? It's 3,6. So the number of moles that we'll calculate for sodium chloride will also be the same number of moles for calcium carbonate. So let us calculate the number of moles of calcium chloride. We will say it is the mass of calcium chloride divided by the molar mass of calcium chloride. So use your periodic table to find the molar mass of calcium chloride. We know the mass is 3,6 divided by 111. So you can find this using your periodic table. You should know how to find it. It's a quite straightforward, simplistic calculations that you should be able to know. So we found that that value, the number of moles, is equals to 0,032 mole for calcium chloride. So we know the ratio is 1:1. This means that the same number of moles for calcium chloride will be the same number of moles for calcium carbonate. So we now have the number of moles of calcium carbonate. We can find the molar mass of calcium carbonate and using our periodic table, and we find that value to be what is it, 100 grams per mole. So now how do we find the mass? The mass will just be the product of these two. So the mass of calcium carbonate is just going to be the number of moles multiplied by the molar mass of calcium carbonate. The number of moles is 0.032 multiplied by 100, right? And we find that to be it's just going to be 3,2 grams, right? But we're not done, because our question wants us to find the percentage purity. So for the percentage purity, remember we need the mass of the sample. We also needed the mass of our specific compound, which is calcium carbonate. So we have just calculated it over there. So now we can actually use the formula for percentage purity to find it. So we know that to find the percentage purity, we simply say the mass of the compound, which in this case is calcium carbonate, divided by the mass of our sample. And the entire thing is just multiplied by 100. So remember the mass of our compound, we found it to be 3,2 grams. Then divided by the mass of our sample, it was given to us as 3,5 grams, and then you multiply the whole thing by 100, and then you get a value of about 94.3%. So that is our percentage purity, and this brings us to the end of this lesson.